For this problem, we have which of the following is true regarding the effect of a single pole on an amplifier's transfer function. Now, when we look at this, the amplifier's transfer function, we have low pass response, and we have high pass response. Now, the first thing that we have here is the magnitude of the transfer function increases by plus 20 decibels per decade as frequency is increased above the pole frequency. Well, we can see for low pass, the magnitude response for a single time constant, low pass, rose off as frequency increases at negative 20 decibels per decade. Well, this is negative 20 decibels per decade, and this is plus 20 decibels per decade. And so this would be false. So A would not be true because we have this negative 20 decibels per decade, even though we have this plus 20 decibels per decade for high pass. So for high pass, the magnitude response for a single time constant high pass increases as frequency increases at plus 20 decibels per decade. But since it doesn't specify it, we can see that this is minus 20 decibels per decade and increases for a low pass. So this is false. So that means also B is false because it cannot be all of these. Now we're going to skip C because that's the correct answer, but now we're going to look at D. In D, it's going to be the same thing. So we have the magnitude of the transfer function increases by plus 6 dB octave as frequency is increased above the pole frequency. Well, if we look at this and we look at what we have here, we have our low pass SDC response. What we want right here is to look at this. Now this is negative 6 dB octave, and it's not a positive 6 dB octave. We can see that the pole frequency is what it's referring to right here. And here we have plus 6 dB octave, but this is not what we are looking at. And then for E, the phase of the transfer function increases by plus 45 degrees per decade from the decade below the pole frequency to one decade above it. Well, we see we have the pole frequency here, and we have the phases negative 45 degrees. So that means that this would be false as well. The most phase shift that is possible from a single pole is negative 90 degrees. This is true, and we can see here that we would be going from about 0 right here to negative 90 right here. So that is the most it could decrease, and that is the correct answer. Another way we could look at this is that we would use arctangent, right? And as this goes to infinity, and if we plug in infinity to an arctangent, we're going to get 90 degrees. And so that's how we know that this is going to be the answer, negative 90 degrees.